Professor Ian Plimer has arrived. Thank you, sir, for coming. Are you well?
Thank you. Sort of, kind of, yes.
Yeah, sort of, kind of.
Yeah. Well, at least it's more pleasant here than doing it from Broken Hill.
Where you'd lost a wheel.
Although I do get a better signal on my phone in Broken Hill than I do in the city of Adelaide.
Isn't that interesting?
Well, yes.
Oh, they keep telling us that, you're in a black spot, almost as if it's our fault. Why don't you pick a black spot to go and live in? No, well, nobody tells you. Speaking of black spots, did you hear about this black hole that they've discovered? Apparently, it is 20,000 times bigger than the sun.
Yes, well, black holes are related to stars that collapse, which is a supernova eruption, and they give out a lot of particles. We see the remnants of these supernova eruptions, and we have a lot of historical records of these supernova eruptions with these bright stars that are bright as the sun, actually. And so it's a collapse, and it's basically it's not a hole, it's the exact inverse. It's where you've got so much dense material, and infinitely dense and infinitely small, that the gravitational field is huge. So light can't escape, nothing can escape. The closest one to us is 18,000 light years away from us, so I don't think we've got anything to worry about.
No, but if you went anywhere near it, would you be sucked into it?
Well, there's two things. There's an event horizon, which is the edge of where you get sucked in, and then when you get sucked into the middle, that's singularity. Now, this is what people like Stephen Hawking and others dealt with. I don't really understand it, but when you're...
Well, if you don't understand it, there's no hope for any of us.
Well, I'm not a physicist, but if you're in infinite gravity and infinitely small size, then the gravitational field is huge. So it's no wonder that nothing can escape.
And there'd be no time?
No, there's no time. And,
no time?
Time stands still. But then again, you don't want to be in a black hole because you'd be totally pulled apart.
Yeah. How did they discover black holes?
I think it was the bending of light. Again, don't quote me on this, but I think it was the bending of light from distant stars that actually didn't come straight and had little bends every now and then. So the gravitational field would have affected the transmission of light. And looking at light from distant stars is a very interesting thing to do. And black holes, there's a great argument about whether these were right at the beginning of the solar system. They obviously continue because we still have them, and we can see supernova eruptions. But we do like to look at light going through or near stars or through exoplanets, planets that are not related to or not in our solar system. And the reason we do that is we measure the light coming through the atmosphere of a planet. And if the spectrum tells you that you have ozone, that means you've got oxygen on the planet. Oxygen you only get from life. You do not get oxygen emitted from any volcanic gases or any eruption. And so the hunt is on to find oxygen in the atmosphere of some planet in another solar system, and that is an indication that there's life there. So there's a lot of instruments out there that are looking, especially instruments outside our atmosphere, such as those on the Hubble telescope. So this is science driven by curiosity, and ultimately that science, there will be some value in it. It's just like the discovery of lasers. It was regarded as being totally useless, and every day we use lasers.
Yeah. A fascinating fact. Caroline dug this up. I don't know, really. She says here, did you know that hot water can freeze faster than cold water?
Well, yes, that's been known since the time of Aristotle.
But it makes no sense.
It's counterintuitive, and we use it today. We use it, for example, in ice hockey. There's a machine called a Zamboni. It goes across the surface and resurfaces it by spraying warm water onto the ice, and that's after each period of ice hockey. Yeah. And they resurface the ice. Now, my son does this. He's had a plumber put in an outside tap for warm water. He lives in Montreal. It gets very cold in winter. When it's below -9, he will then spray warm water into an area that he's got wooden panels around and got a tarp at the base, and he's made quite a big ice rink for the 3 kids.
Golly.
And so he builds up the ice. He's got to have it less than -9, and he's out half the night building it with one little spray, and then it freezes, another spray, and then he freezes it. So these kids are outside in winter when it might be -10 or -15 or so, playing ice hockey, which means they're out in the fresh air and they're getting exercise, and they're great sporting kids. So we use that. We often see pictures of people in Antarctica with a boiling kettle and throwing it into the air, and it freezes. Now, this was discovered by a kid from Tanzania and a kid called Mpemba, Mpemba, and he suggested in school that if you warm ice cream before you freeze it, it will freeze quicker. And of course, everyone laughed at him until they tried it. And we don't really know why it happens, and it doesn't always happen. Also, some suggest that with warm water, you have a freezing because of a change in volume very quickly. Others say, well, with cold water you get a frost layer on the outside and that insulates it. And others say, well, when you boil water you get rid of some of the dissolved carbon dioxide and other materials, and that changes the freezing point. So it's not universal. It's quite exciting to see this phenomenon, which is called the Mpemba Effect, after
it's actually got a name.
And Erasto was a kid in the 1960s.
Oh, yeah, Mpemba.
Yes, yeah, typical African, you can't pronounce it.
Is there anything you don't know?
Well, no, wait a minute. And that's not correct. The listeners should be aware that Jeremy rang me yesterday and said, well, we're going to talk about this subject, and I'd heard about it, and I had to look it up. And as you notice, this is the first time
he's not only brilliant, he's honest.
Had some notes here for me. Most of the stuff I can retrieve from the memory, but this one I was aware of, but I had to get a bit more information.
Something I heard this morning which I thought was absolutely startling. Products that we really take for granted and are quite dangerous. They sell 300,000 tampons. It's either a week or a month or a year or something. And they've discovered, maybe for the first time, they have looked at exactly what is in a tampon. They have found, and this is a university from, I think it's Berkeley, California, they have found arsenic, heavy metals, lead, things that you really would not want to have anywhere near, let alone in your body, and not one sort of warning on any pack that there may be consequences. And the professor was asked, well, is it dangerous? Well, actually, we don't know. But logic would say yes.
Yes. Well, there's a lot we don't know, and my immediate sceptical brain says, well, what was the concentration of the arsenic and the lead, etc.?
Yes.
You can detect...
But these things can be cumulative as well as residual, can't they?
Both are cumulative, and you can detect arsenic and lead down to parts per trillion.
Yeah.
So if you had, and Berkeley does have these instruments where you can detect material down to that level, then yes, it contains arsenic and lead. But it's a cumulative poison, and arsenic is a very interesting substance. We need a little bit of arsenic in our body, but you can have too much. Now, if your spouse is trying to use an old-fashioned way of doing away with you and gives you a good dose of arsenic, then you have a very good chance of dying.
I'm trying to think of her name, Emily Perry.
And however, if you are suspicious that she's trying to do away with you and inherit the family dog, then what you do is you take small doses of arsenic and keep increasing them.
Okay.
And when she comes in for the kill, you actually have a resistance to the arsenic and you don't die. Now, that's the same with radiation poisoning. If you suddenly get a dose of radiation, it could kill you. But if you have a low dosage of radiation and it's over time, then it may not kill you. And this was certainly the observations we learnt from Hiroshima and from Nagasaki. So there was a time once when we used arsenic in cosmetics because arsenic salts are coloured. And this is why in ancient times kings and pharaohs, etc., had many wives because they dropped dead with arsenic poisoning.
And didn't they use lead-based makeup?
They used lead-based... I'll come to lead in a second. They used lead-based makeup. And they also used arsenic to give the green colour in wallpapers. And there is a view that Napoleon suffered arsenic poisoning from the wallpapered rooms that he had, and the French used a lot of this green iron arsenic compounds in their wallpaper. So arsenic is a cumulative poison. You can leach it out of your body. It's very easy to do with certain chemicals, the main one being a chemical called EDTA. But lead is also an interesting poison. Lead is cumulative. You can measure lead, and at all the lead mines around in the world, people have a quarterly measurement of their lead in blood. And the way you get lead poisoning now, if you're working in a lead mine, such as Broken Hill, it is well known that if you are welding and there's some lead minerals on the surface, you will vaporise the lead, inhale it, and that then goes into solution in your blood. Another way is not washing your hands before you eat. Another way is smoking a rollie, where you might have had a little bit of lead sulfide dust in there, and that then ends up as gas in your body. And the last way is that if you're mining minerals that are slightly soluble in water, this was the case in Broken Hill up until the 1920s. The incidence of lead poisoning there was just appalling, and that's because they were mining lead carbonate, which is sparingly soluble, especially if you're perspiring, then it will dissolve more quickly in slightly saline waters. And lead poisoning, again, can be very easily detected. And lead poisoning is cumulative. Lead poisoning gives central nervous system damage. It's especially dangerous for children. And so a small amount of lead is in everything we use.
Yeah. I remember when I was growing up, not that I've ever really
No, you haven't
finished.
grown up.
I don't want to, actually. But there was a big thing about lead soldiers. And children would play with lead soldiers and put them in their mouths, and they used to call it, I think, infantile paralysis.
Yes. Well, that was metallic lead, which is sparingly soluble in a saline solution, which is your perspiration or which is your saliva. So, yes, and I remember those lead soldiers. I had some myself. We use lead all the time. We use it in solder. We use it for lead. Used to be used in paints. It was lead salts. Were some of the petrol, but lead salts were the whitest substance known to man, and so that was used in paints, and especially for undercoats, and especially for the body whiteness in the top coat. Now we use titanium dioxide, which is completely insoluble, and it's whiter than lead salts.
They used to use lead flashing on roofs.
Especially churches. And the bad guys used to get up and remove the lead flashing when the lead price went up, and it's fairly high at present. And that lead flashing would get a passivation layer on it, as we get with aluminium or magnesium or many other metals. And that was an oxidation layer which would stop the lead dissolving.
But what would that do if you had a rainwater tank and your water was coming down?
Well, again, with lead metal, it wouldn't give you enough lead to poison you. But if you're in a mining town and there's a dust storm and you've got tanks, you will get lead poisoning. And this was a very common case in Broken Hill. And in fact, in the Spud and Onion strike of 1919-1920...
Spud and Onion strike?
Yeah, well, this is where waterside workers around the world provided spuds and onions, which would travel, for the people on strike at Broken Hill. And they were on an 18-month strike. And that was in return for the Broken Hill unions providing food and money to waterside workers striking around the world. Now, this strike was about a safety issue. And the safety issue was lead poisoning. And the companies just wouldn't believe it. Eventually, after the long strike, the Chief Medical Officer of New South Wales did a survey of all the workers and, to his horror, found out that the unions were correct, that there was massive lead poisoning in the community. And so there was a complete renegotiation of conditions. The workers then got a lead bonus, and this was based on the quarterly London Metal Exchange price of lead. This was compensation for any lead poisoning. This was the first occupational health and safety that occurred in Australia. And what grew out of that were the Occupational Health and Safety Acts in all the states. So lead can be very useful, it can be very dangerous. And it's like with all these substances, you use them with care. We used lead in petrol to stop knocking, to stop pre-ignition. And we've now removed that because that lead gave us vapour, and we know from lead surveys along the edge of freeways and highways that there's a contamination of lead along the edge of the highways. And we're able to work out where that lead comes from because there are various chemical fingerprints, isotopic fingerprints in lead to tell you where it came from. Now, most of the lead in our petrol in Australia comes from the Massif Central in France, where it was mined for most of the 19th and 20th century. Even though we've been a very big lead producer, and Port Pirie here in South Australia has been the world's biggest lead smelter, we didn't use our own lead. We used French lead in our petrol. So you can actually work out a lot from looking at the chemistry of these, and we do know a lot about lead and lead poisoning because it's been an industrial contaminant for a long period of time.
And mercury?
Well, mercury is highly toxic.
Well, they found mercury in the tampons as well.
Yes, well, mercury, we all used to play with mercury as kids. It's a liquid metal at room temperature. It's highly toxic, but its most toxic form is in mercury organic compounds. Now, we get some mercury organic compounds in gas, in natural gas. And so between the well and when it gets into the pipelines, there are separation plants that take out the mercury compounds, take out the carbon dioxide, take out any nitrogen compounds. It's well known that Bass-Strait oil is quite rich in mercury and rotten egg gas. So
hydrogen
mercury,
sulfide.
We're very, very careful with mercury, and we know that because of Minamata disease. And there was a smelter at Minamata Bay in Japan where mercury was released. It got into the ecosystem, it got into the small fish, it got into the bigger fish, it got into the really big fish. And as you know, the Japanese diet has a lot of fish in it. And people were suffering central nervous system damage from mercury. Mercury in its salt form is highly toxic. Liquid mercury, some of it vaporises and you breathe that in. That's highly toxic. Mercury is a terrible toxin. And I once went underground at the mercury mines in Almadén in Spain. And these are mines that have been operated by the Carthaginians, by the Romans and by the state for 2,000 years. And there was the crimson mercury mineral cinnabar, plus there were little cavities with liquid mercury in it. And you'd break open a rock and mercury would drip out. God knows what the vapour was in there, but my wedding ring had a slight hairline fracture in it, and it broke and it dropped somewhere underground in the dark. It's still there. And so...
You're still married?
Well, yeah. Oh, yes. And mercury is used... I went to some mercury mines a few years ago in Western Anatolia. And these were mines that used mercury to make mercury fulminate, which is the detonator in shells and bullets. And so and I was thinking when I was there, well, these Turkish mercury mines provided the detonators for the Turks, the Ottomans,
the Gallipoli.
Yeah. And when I go into these villages, and they're like that in some parts of the world, you have to employ someone, and the head man asked me to employ this young boy, and he was severely mercury brain damaged. And he showed me all the old mercury mines. I was looking at the mercury because beneath mercury deposits you often find gold deposits.
Huh?
So I was sniffing around. This kid was yelping and carrying on, and I took a photograph of a stream that had ice crystals growing into the middle of it, which is exactly what you see with quartz veins in nature. And I was quite interested in this. And then this kid took me to every stream with ice in it, and then he saw me bashing these rocks with a hammer and putting them in a bag, and he was fascinated with my hammer. And at the end of the middle of the day, we sat in a ravine and in the sun, out of the wind, and had some food. He had no food. He only had plastic shoes on, no socks. So I fed him. And then when I eventually got back to the village, I had to pay the head man for the services of my guide. I didn't need a guide. I mean, I could find my way around. Anyway, I thought, well, I'll give this kid my geology hammer. And that was the greatest present I could give him. I gave him the hammer, and he went down the cobbled main street, yelping and shouting and swinging his hammer around. He probably smacked himself on the head. But anyway, the village looked after this kid. And the village, the kid's probably not alive now, but the village had a sense of community. And everyone had their place and their role. And those who were brain damaged, they actually looked after them. And to me, it was a great thing to see it. I wrote this up as a little short story, actually. I think I published it somewhere. I think it was in The Spectator. But it was very touching to see how the village looked after someone who was mercury poisoned.
Yep. This is along the same lines. The average kitchen is full of objects that release microplastics into food and drinks, whether through plastic cutting boards or the lining of tea bags. Now, they're saying here that tea bags, if you drink enough tea with tea bags, and I do, I don't know, I have 12 cups a day at least, that you are accumulating a lot of bad stuff. Humans constantly inhale and digest microplastics, fragments of any plastic that measures less than 5 millimeters in length, lurk in oceans, the air, food, drinking water, tea bags. I mean, this world is an obstacle course. I'm surprised that any of us are alive.
It is, but, I mean, 12 microplastic tea bags a day, I can see the results. Yes, it is.
Is it that obvious?
Yes, it is, yeah. It is. The second head tends to move a little bit. Yes, we are in an obstacle course, but you have to remember that we're living a better life, we're living longer, we have better health, we have better wealth. We are living in much better times than now, and microplastics are everywhere. If you are drinking out of bottled water,
there's Tony.
That's a very good way of getting microplastics. Tony, who's opposite me, has just had a swig. So if you really want to avoid having a good dose of microplastics, drink tap water. There's nothing special about bottled water. It is tap water. Refilled in the bottle, so you're still getting plastics. Yes. So the microplastics in the ocean, I believe, are a major problem. Again, this is outside my area of expertise, but I do read widely. I'm a bit of a polymath. And that's one of the things of the modern world: plastic, fertilisers, cement, and steel.
Les wants to say a word to you.
Professor, good morning. Last week we were talking about flatulence and cows, methane. But Professor, I understand there are something like 30 active volcanoes on the planet, and there's regions like the Ring of Fire around the planet where a lot of activity, and I also understand about 80% of volcanic activity emanates from under the ocean floor, or from the ocean floor. When we consider volcanoes and the amount of carbon dioxide emitted from volcanoes, which I understand to be in the order of 120,000 tonnes a day, are we as a human race a bit precious and a bit overly clever, thinking that we can control the climate by regulating the
net zero
methane output of the humble cow?
Yeah.
Well, I think we've been drinking substances that affect the brain. We have 1,800 volcanoes that are terrestrial volcanoes that we can see and that are active. Terrestrial volcanoes emit very little methane and very little carbon dioxide. At last count, we had over 3.5 million submarine volcanoes. These are on the mid-ocean ridges. These are off-ridge volcanoes. And these emit masses of carbon dioxide. And the reason for that is that the chemistry of terrestrial volcanoes is very different from the chemistry of oceanic volcanoes. And in the oceanic volcanoes, which are basalt, you can dissolve an enormous amount of carbon dioxide compared with a terrestrial volcano. So as the molten rock rises, it's releasing carbon dioxide into the ocean, and what we cannot do is to predict where the next eruption is so we can make measurements. But we do know from volcanic glasses on the seafloor, we can measure the amount of dissolved gas in that, and that's after we've lost most of the carbon dioxide, and the content is very high. Now, this carbon dioxide does not bubble to the surface. It dissolves in the cold, saline bottom waters, and eventually, with upwelling, comes to the surface and is released to the atmosphere. So we have a cycle of carbon dioxide. We know that deep in the planet we have methane. We also have carbon dioxide. We have other compounds such as carbides and diamond and graphite. So we have a carbon cycle constantly circulating carbon dioxide. We have parts just to the north of New Zealand. On the ocean floor, we have liquid carbon dioxide on the ocean floor. So we have a lot of carbon dioxide sitting in the oceans. We also have a lot of methane as a methane combined with water. And these methane hydrates always form at a certain temperature and a certain pressure. And if sea level lowers, we release these. If sea level rises, we actually dissolve more in the ocean waters. The Japanese have spent a lot of time and money looking at this as a source of energy. So when people do their carbon balances to try to tell us that we're all going to fry and die, they never consider oceanic volcanoes. We can measure what's coming out of terrestrial volcanoes by putting instruments there, but we don't have the instruments on the seafloor measuring them. So we're very much in the dark on the carbon cycle. I would argue that the natural emissions of 97% of the total, and that's from ocean degassing and respiration and from some volcanoes, is probably an underestimate. It's probably a bit higher.
97%?
97% of all carbon dioxide emissions are natural.
So the little tiny bit for which humankind is responsible, maybe, this is what we're agonising over.
Well, we're agonising in Australia over 1.3% of 3%, which are 9 parts of 5/5 of bugger all.
It's beyond belief, isn't it?
So we're making trillion-dollar decisions based on traces of a trace gas. But it's not an attack on carbon dioxide to change climate. This is an attack on industry. It's a move to deindustrialise society.
Yes, I believe that's true. Yeah.
It's got absolutely nothing to do with the environment. You've only got to look at what these offshore and onshore wind turbines do, what the solar panels do. This is an attack on our way of life, yet those who are attacking don't face an election. Those who are attacking don't live in caves. Those who are attacking have a political motive, and that is to deindustrialise the West.
What could be the reason for that? What would motivate people to want to deindustrialise the West?
Well, these people do it for ideological reasons. And
what's the world going to look like if they succeed?
Well, we don't have enough caves for 8 billion people.
No, exactly. I'm going to the cave business tomorrow. We will rent a cave.
Well, we have a housing shortage. Maybe a cave is the place to do it. The problem is with the current climate cult, and it is a religious cult, is that they don't look at evidence and they don't look in the past.
It's voodoo, I know, it is. It is. It's wonderful to see you, Professor.
Thank you for having me.
If I could find a way of patenting, registering... Caves. No, this man's brain.
Well... Yeah.
And if I could get yours as well, I think, and yours.
Shared around.
One of the most disappointing things about the human brain is when you cark it.
What happens to it?
it just all disappears. All that knowledge disappears.
It's a great pity.
So you spend your life learning, and I still am learning. I'm really loving learning. And then it's really unfair. You don't genetically pass it on.
Can't you download it?
Well, I do by writing books and writing scientific papers and programs like this. Yeah. But it's unfair.
Well, I want you to come back and download again next week, if
Thank
you'd
you
be
for
so
having
kind,
me.
sir.
Thank you.
Thank you. Thank you for coming by. I hope you get the wheel. It's out there somewhere.
You're going to buy this cocaine.
I'm going to go down there today and give them a bit of a hustle.
It's a Bentley wheel.
Yes. But, you know...
But remember that company I mentioned to you, the Flying Spares,
Yes,
because they actually...
Well, I'm going to go down and make sure that they've got it, and it's mid-air or it's in customs. If they haven't, then I'm into Flying Spares.
Great to see you.
Next week I'm in Broken Hill, but I can do it at 10
Okay,
a.m. Yeah.
all right, that'd be wonderful.